Welcome back to episode 10. I'm going to try to get this episode in less than half an hour if possible. I have this idea that I came up with a long time ago. In fact, it was like 6 years ago or something when I actually programmed this the first time. But it's an enemy that chases you on a wrapped screen. So let's say you're the circle and the enemy's the X. There's a specific way that I wanted the enemy to chase you, depending on the distance from you. So this enemy has 4 directions he can go. One direction is there. The other direction is there. The other direction is there. And of course, the other direction is there. Now, to decide which way to go, I wanted to go, let's say I decide that I want to, that the closest to, that, let's say I'm going left or right, that I decide to move left or right instead of up or down as the enemy. The way I would decide to go this way rather than to the right this way is that this is shorter. But when I compare the left and right to the up and down decisions, I would go the longer route. So if my 2 options for going horizontal and vertical were this and this, then I would choose left because I want to close the space between us as soon as possible. But if the choice has to do with me going left or right and wrapping all the way the screen, I want to go left because, well, in this case, I'm going to move to you as fast as possible. But the reason why I choose left instead of up, the reason why I choose the longer one here is because, well, even though I can only move like increments at a time. So let's say I have to move 2 up and 3 left. It doesn't really matter whether I go up or left first. I will still go exactly 5 hops. But in real life, let's say if I didn't have to follow the whole, the street pattern along the grid, I would kind of go this way. So if I had to choose which way would kind of replicate that the most, which way would kind of look like that the most, then as you can see, the arrow is closer to the bottom side, so I would choose the longer route between those. So the way we're going to decide whether we're going to go, what our distance from the enemy is we're actually going to subtract the coordinates. So if I take x as x and I subtract O's x, then I'm going to get some difference, some distance between them. But in this case, it's going to be a positive distance. So if that positive distance is, if it's greater than 8, then that means we're going to want to go to the right. But if it's less than or equal to 8, we're going to want to go to the left. But if it's a negative difference, then it's the opposite. So if it's greater than 8, we're going to want to go to the left, and if it's less than or equal to 8, we're going to want to go to the right. So the easiest way to do this is to take whatever number this is. Let's say this is dx, okay, and we're going to multiply that by we're gonna take that and we're going to we're going to decide let's see here. If it's positive, then the actual number, if we subtract 8 from it, we'll see if it's greater than or equal to 0, I believe. We can take the absolute value or something like that. But anyway, we can find out what's the distance we're going to go, because we basically, if it's greater than 8, we just take 16 minus the absolute value of whatever it is, and that will be the distance we have to go in the other direction. So the point is, I want to take the route that would make the most sense, the route that looks most like real life. So let's go ahead and program this, and I'm going to call this tag. Okay, so we're going to basically start off our coordinates, and then we're going to have our enemy's coordinates. Here's going to be, I'm going to get our erasing coordinates ready, and then our enemy coordinates are going to be N and O. Oops. Okay, so okay, so basically what I'm doing here is I'm checking if we moved, and then I'm going to check if they moved. We will look like a theta. They are going to look, I guess we can use an X for them. So yeah, that looks good. And then we're gonna get the key, of course. And then we're gonna do all of our controls. Okay. Okay, so there's our controls. We can put all this inside of a loop. X stores S and Y stores T are going to be down here. And we'll just put a loop around the entire structure. So I can move around. Something's wrong with my erasing. I'll have to check what that is. Oh yeah, it's because, well, no. Oh yeah, it's because I need to do the changes. So I should have put these under the outputs. Okay, so X and Y, N and O, all these are getting stored as these variables. There we go. So I can move around. Let's go ahead and clear the screen first. Okay, so we got both guys up on the board. Next thing we need to do is we need to check the variable difference. So we're going to change his variables now, based off all this, all these calculations that we've done. We're going to try to determine whether he's going to move up, down, left, or right. So we'll see. First, let's make us wrap the screen. Okay, so if x equals 9, x equals 0, y equals 9, I'm sorry, this is 7, we'll do 0, 17, 0, y equals 9. Oops. So 16 stores x, 0 stores x, 8 stores y, 0 stores y. There we go. Now we can wrap the screen. Oh, what did I mess up? Oh, 1 stores x, I'm sorry. And 1 stores y, of course. There, now we can wrap the screen. Perfect. So now we can work on him. Let's make him make the correct decision on how he's going to chase us. So we're gonna find the difference in his y and his x from us, but we're going to modify it so that it's always in terms of wrapping. So let's say we're all the way on the left side of the screen and he's all the way on the right. That should come out to be a very small difference in x, because let's say we're at 1 and he's at 16. Well, this difference between them is going to be 15. But when we modify it, if we mod it with 8, then we get 7, which is actually still a large number. Let me think about this for a second. If we're at 2 and he's at 9, that should be far. But that's also a difference of 7. So we can't mod it by 8. That will not get us the correct. If we mod it by 8, then we'll have to negative it, maybe. Because what we want is a difference in width. Hold on, I've got to figure this out a little bit. So let's try to figure this out. Let's say my x, or we're going to compare our x's together. So if we're at 1 and he's at 16, I want the difference to be 1. Okay? But if we're at like 5 and he's at like 12, then I want it to be 7. So modulating maybe by how close it is to, not sure. So how do we do that exactly? If we modify his, if we subtract his coordinate from us, okay, so this is our goal coordinate. Let's use D for distance. So 15 will be there, 7 will be that. Not sure how we get 15 to 1. If we're at 2 and he's at 16, then the distance is going to be 14, but we should be 2 away from him. And if we're at 3 and he's at 16, then the difference is going to be 13. But we should end up with a 3. Because basically he's at, in a sense, he's at 0 compared to us. So I'm not sure if I should modify his coordinates. No, because then if he's at 8 and we're at 3, the distance should be, will be 5. And we also should be exactly 5 away. So somehow, given these 3 columns, I need to get this column. Not sure how I'm going to do that, because I feel like I had less trouble figuring this out years ago. Don't know how I figured it out so easily back then. Yeah, I must have been better at figuring things out back in high school. So the distance mod 8, I'm not sure if that's going to help at all, but that's 7, 7, 6, 5, 5. So I'm going to put a remainder next to it if it was modified. So the ones that are modified, it seems as though they might be closer. 8, and then, no, let's go with 9, and his x is 1. Okay. If we were to move, if he were to move to the right, it would take him 8 blocks to reach us. But if he were to move left, 16, 15, 14, 13, 12, 11, 10, 9. It would also be 8 blocks. So this should be 8. The distance obviously is 8. Or we could actually put -8 here because he's on the other side. And then the distance mod 8. I'm not sure if I would leave it at -8 or if I would bring it to a positive number. It could be 0 with a -1 there. So I remember taking the absolute value of something like twice inside of itself. That's what I remember doing. And I was subtracting 8 and adding 8 both times. I was taking the absolute value, I think. That's what I remember from the last time I programmed this. But I do see a pattern here, kind of. I see that these ones tell me when I have to basically revert to going the opposite way. So yeah, maybe let's just assume let's assume for now that we're at 1. Okay. For 2 through 8, 2 through 9, he needs to move right. He needs to move left if his coordinates is 2 through 9. But if he's 10 through 16, he needs to move left. So our distance here is 1 through 8, and here it's 9 through 15. Okay, so if our distance is 16, then that means we're actually in the same position. So I think it's just our distance. If our distance is greater than 8, that will determine which way he goes. So if we take his distance and subtract 8 from it, that'll give us a positive or negative number on which way to go. So let's go back up here. Yeah, let's go with this. By subtracting 8. So yeah, we'll do this. If his x is n, so if n minus 8 and I'm starting to think not n minus 8, but we'll take the distance between us and call it n minus x, and that'll be the distance, which is, we'll call it u. Okay, so if u is positive, or let's multiply them together. So we'll take u and we'll multiply it by u minus 8. If that's greater than 0, then I'll just guess we're going to go left. It might be the other way around. We'll see. I'm really bad at thinking about these numbers and what they actually mean. If n equals 0, 16 stores n, and then here, if n equals 17, then 1 stores n. Okay, now let's go back to tag. Okay, so he's getting as far away from possible as possible for me. There we go. You see that? He follows me. Uh-oh. Is he following me the right way, though? No, he's not. Because watch. As soon as I do that, he goes the wrong way. So, I did something wrong here. He follows me. So if I'm at 16, if I'm at 16 and he's at 1, we want him to move left, not right. So let's see what it is. So 15 minus 1, that's, or 16 minus 1, that's 15. So we have a positive number times that minus 8, which gives us positive times a positive, which is greater than 0. So he's going to move to the right. But we want him to move to the left because it's a shorter path that way. Now what? Did I do this correctly? I don't think I did this correctly. His x. I did this correctly the first time I programmed it. Why do I have to not know what I'm doing now? 16 minus 1 is 15, which is positive. Which means he's on... I'm sorry, wait. He was on the left. So 1 minus 16 is negative 15. So he knows that he's on our left. And since the distance is greater than 8, he should move left. I believe maybe I... It's almost like... Well, he tries to get me... If I'm on the right half of the screen, he's stuck in between. If I'm on the left half, yeah, this is not... I'm not doing my theory correctly. Yeah, this is not correct. Yeah, let's work this out. So my coordinate, or his coordinate minus my coordinate, will tell us two different things. Actually, I remember when I did this the first time, I had done it this way. I had all the possibilities, and then I used modulation, or I'm sorry, I used absolute values to figure out which direction. So I think this was the 4 possibilities. Okay, so I wanted to determine which column and which rows you are in here and multiply them together to get the correct direction that he should travel. So we know here it should be left, here it should be right, here it should be right, here it should be left. So it's really easy to tell which column we're in because the left column, the distance is going to be a negative, or I'm sorry, the distance is going to be positive, and the right column, the distance is going to be negative. So that's easy to tell which column. Now to tell which row that we're in, we need to be able to tell how far apart we are if that's greater than 8. Ah, that's what it is. Okay. I realized that's basically what I was doing, but this is what I was missing. The absolute value of u minus 8. Because if let's say u is negative, then we're just subtracting from it. So we need to make it positive no matter what. That's what splits that's why he was only doing it correct one way and not the other. So here we go. Now he will go, wait a minute. No! We still have the problem that we had before. Okay. So I was so sure of that. I was so sure. I was so absolutely sure. So let's figure out what I was doing wrong. So we have D, which is n minus x. Okay. We'll call it u. U is positive, and u is negative. So u is n minus x. So that tells us which row, which column we're in. I think we've got that down. But to see whether our distance is, let's see, what is the distance here? This is probably u equals 2, u equals negative 2, u equals negative 15, U equals 15. Oh, you know what it is. I think I know what it is. If I take the absolute value of that minus 8, I'm sorry. I need to take the absolute value of U, and I need to subtract 8 from that. And then, yeah, that's what it was. Okay. Whew, I am so sorry. I am doing so horribly. It looks like it's functioning perfectly, except obviously it is switched. So we actually have to put a less than 0 here, and there we go. Now, no matter what, the x should follow us. Perfect, perfect, perfect. Okay. Now the y, the y can be done pretty much the exact same way. So I'm going to take O minus y and store that into v, and so that's going to be the difference in y. Yeah. So for now, I have an idea. I'll just do a random. We'll just use random for our advantage right now. So if random 1 and 0, then so if that happens to be a 1, then we'll move the x. However, if it doesn't, then we'll move the y. So we're going to say if v times v minus 8, and that's the absolute value of v, minus 8. If that's, I believe it's less than 0, then we will move one direction. We're going to move O plus 1 stores O. And then here we're going to move, wait, let me just double check, because I do want the pluses and minuses on the same side as the other one, just to keep it consistent. The reason is, even though we can switch the if statement, I don't want to have to use like greater than for one and then less than or equals for the other, because we have to worry about like including 0, and I want to be able to keep it very symmetrical in that sense, so that it's easier to perfect it when we want to go back and like correct things and make it so that we don't even move, the x if the x equals our x, if we want to make it more precise like that. So here we go. If O is equal to 0, then we're going to store 8 into it. And if O is equal to 17, I'm sorry, 8. 9, then we're going to store 1 into it, and there we go. Let's run tag again. We'll see if it follows us up. Yes, it does. It follows us down. It follows us all around, and we have an enemy that chases us now. So right now the enemy chooses randomly whether it's going to go up, down, left, or right. So we want to go in and we want to decide which of these situations. Now we want to decide. We already know which direction we can move, but now we want to actually be good at deciding. You know, are we actually closer x-wise or y-wise? Because in this sense, you know, this, we're part 2. Our distance here might look like it's 15, but I think we would just modulate it by 8, and maybe we wouldn't modulate it by 8, but how would we get 1 from this? How would we find out that this is actually 1? Not sure. So we need to write somehow we need a function that says, you know, 15, you know, plus or minus 15 gives us 1. Plus or minus 2 gives us 2. So obviously we're going to have an absolute value in it, but we just want to decide what makes distance greater. So plus or minus 7, you know, that gives us 7. Plus or minus 9, that's also got to give us 7 because it's not 8. It's shorter to go the other way around. How? It's not a mod 8. This isn't the mod function, but it's something. It is something very simple. Let me try. That gives us 5, but plus or minus, like, let's say 11. Like, what's 16 minus 11? It's just like 5. So that's also 5. I guess it's how close the number is to 8, but like the opposite of that. So like 8 minus how close the number is to 8. So I guess it would be, because both of these are the same distance from 8. Both of these are the same distance from 8. Both of these are the same distance from 8. So we need to like take like distance minus 8. Whatever that is. Does that really give us? I guess it does. Yeah, I suppose it does. So we want to do the one that's the least though. So whatever distance minus 8 is less is the one that we actually want to decide on. So if we take u and we subtract 8 from it, or we take the absolute value of u, subtract from 8, if that's greater than the absolute value of v minus 8. But not necessarily minus 8. That's the thing. We want the distance from 8. Because if we subtract 8 from 2, then we get negative, negative 6. So man, this is confusing me for some reason. It's a better way to interpret this. What I want is this number somehow. I want its distance from 8. But I guess 2 minus 8. I guess 2 minus 8 would be sorry about that. Camera's attached to a pole with another device that attaches cameras to things. I guess the difference between 8, distance between 2, it's not the distance from 8. It's the distance from 16. Oh, I know what it is. It's the distance from either 1 or 16. So I take the distance from 8. Aha. So I need to see how far from 0 or 16 it is. So what I do is I take the distance from 8 and I take 8 minus the distance from 8. Because this will be like 6 or something. Like let's say it's 2. Yeah, so this should work. So 8, I take 8 minus that because, like, let's say I'm either the number 2 or I'm the number 14. Both of those are only 2 away from the edge of the screen, but they're 6 away from 8. But if I take 8 and I subtract 6 from it, then I get 2 either way. And I also get 6 when I take the distance from either of those to 8, because I take the absolute value. So if I take the absolute value of the number and I take the absolute value of that minus 8, now I need to subtract 8 from it. So if 8 minus the absolute value of u minus 8 is greater than 8 minus the absolute value v. The absolute value of u minus 8 is going to be the distance our number is from 8, and then 8 minus that is going to be our number, which means we probably don't need the 8 minus in our comparison. Yeah, so what I'm going to do is I'm going to loop us a couple times. Or what I'm going to do is I'm going to put an if, and I'm going to give us a random integer. If that equals 0, so 0 to 4, so there's a 1 in 5 chance that our enemy can move. If that equals 0, then he can move. Oh, for some reason that's not really working too well. There we go. So he can move some of the time now. Not very often. But notice he's going to close the distance first. So he's going to move his x first. But whatever one's further away, he's going to move that one first. Okay. So what we can do now is, since we're playing tag, you know, he's chasing us. We can make him a little bit faster. Let's do the random number between just 0 and 1. So he's pretty much half the speed we are right now, based off random chance. And I'll be, but yeah, let's make it so that we can tag him, and then once we do, he runs away from us. Okay. Okay. So oops. What I'm going to do is I'm going to have a variable called t for tag. And I'm going to store 0 into it to start off. Oops, that's y. And whenever it switches, we want to reverse what he does. So if he touches us, we want to switch the fact that he's running towards us and make it so that he runs away from us. So let's go down here. Yeah, so we'll just check it right here in the last loop. So if x equals n and y equals o, then we're going to change the value of t to be the opposite to make this a full game of tag. So let's go up here. We want to do basically I think we want to do like the opposite. Although there is an issue. What we could do, there's a strange issue with this. One stores T. Okay, I think I know how to fix it though, because we might be able to use exclusive OR. So I'm going to use T as what we add to his values. For getting closer or further. But that means that we also need to check the opposites. So if n equals, for example, 17, we need to store 1 into n, and all of these little, these little things here. Oops. Oh, no, that's fine. If n equals 0, 1 stores n, 16 stores n, and down here, if O equals 9, 1 stores O, and if O equals 0, then 8 stores O. So basically when he touches us, he's going to do the opposite. Oh, I totally messed that up. Totally forgot that I'm already using T. Let's use B. Because B is not in use already. And let's reverse whatever B was. Uh-oh, something's wrong with our domain. Oh, and it looks like we have to actually store, just to initialize our values, and this is a good thing to catch, but even though I moved them earlier, it's still important that we set these because we use them before we actually set them in the loop. Okay, so moves towards us. As soon as he touches us, moves away. However, there is the issue of he moves horizontally when he's further away horizontally, which should be reversed. So the way to reverse it is we're going to actually exclusive OR we're going to exclusive OR our choice of X and Y. So all this logic right here, we're going to XOR it with, I guess, T equals, I'm sorry, not T, B equals Is it 1? I believe it's 1. Maybe it's b equals 0. Or b equals negative. B does not equal 1. We'll just say b equals negative 1. So as soon as he touches us, he wants to get away, and notice how he gets away whatever the see, so if we're closer on the x, he'll move away. If he's further away on the x than on the y, then he'll move away on the y instead of the x this time. He wants to move away whatever distance is shorter, not whatever distance is longer. When he moves closer to us, he wants to move whatever distance is longer. So now we correctly made a tag game, and it's going to be hard for me to get him. So what I might do is I actually might make him a little slower when we're... Oh, it's so hard. Okay, so do you see how I tagged him? What I want to do is I actually want to have a timeout where he changes his appearance, so that there's kind of a delay before and after tagging of him and him tagging us. I want him to kind of be like, I guess, confused. So I'm gonna make him look like a Z. Okay. If he's confused, and I'm gonna use R as the counter. Or no, let's use C, since C stands for counter. So if C is greater than 0, then he's gonna be a Z. However, if it's not, then he's gonna be an X. Now C is gonna start off at 0, so we're gonna initialize it to 0. And what we're gonna do is we're gonna come down here, and when we check for when we're touching each other, instead of negating B, what we're gonna do is we're gonna set 5 as C. That way it kind of changes, like the timeout kind of changes. And let's also make it so that we can't reset it. So as soon as we touch, we can't set C back to 5. So if those are all true and C equals 0, then we can set C to 5. Okay? And we're going to subtract. So we're going to say if C, then we're going to subtract 1 from C. So C minus 1 stores C. So as soon as C is 0, then it's just going to stay at 0. Nothing's going to change it unless we touch. But if C is 1, exactly 1, then we're going to, that's when he switches. So actually, let's do it right when it turns 0 for the first time. So let's do this. Negative B stores B. So if C equals 1, then negative b stores b, but no matter what, we're going to subtract 1 from c. So that means that he's going to, when we tag each other, he's going to have a 5-second or a 5-move change of heart time, and no matter how much we touch each other during those 5 moves, nothing's going to change. It's not going to even reset to 5. It's not going to switch who's it. It's not going to do anything. It's just going to start the process of him switching. So you notice he tagged us, and that it gave him a chance to, and he kept chasing us. So what I'm thinking is, what I'm actually thinking is, I think we should, while he's in that stage, I'm thinking we should actually force him, no matter what, to be afraid of us. That way he's not like on top of us when he chases us and then tags us. I want him to actually I want him to get away from us during those 5 seconds. See, he's like chasing us, and now he's getting away. Actually, well, he should have been running away. When I tag him, he should actually run away. Let me see. Okay, this is too hard. That means it's fun. That means it's a good game. Let's see here. Before we change that, we're going to just slow him down a little bit so it's easier to tag and not tag him. So right now he's chasing us. Now he's got that 5-second delay. Okay. Maybe 5 is too short, so what I'm going to do is I'm going to change it to I think 15. Or actually 20. Let's just leave it a high number for now. Anyway, if I tag him, he's still chasing us, which is bad. Now he's running away because he switched. And now he's still running away, but then he'll chase us. So what I want him to do is I want him to always run away. So here he is, he's chasing us still, and now he's running away. So let's see, what's the state of B when he's running away? It's -1. So I want him to be in -1 when he's in Z mode. So let's go back to tag. So we'll just manage that down here. So we want B to be -1. We want B to be -1 when he's in Z mode. So if C equals 1, let's see here. I don't know how to do this without using another variable, but I might have to. I guess we might need to use another variable. So let's store 0 into z. So z mode is going to be off, but when he's in z mode, one stores z. But we're only going to count it if we're switching to, so we want to set 1 as b, which is him chasing us, if z was negative. So if c equals 1 and z is 1, then he's going to chase us. So we don't want to set z unless, oops, okay, so we're going to store z 0 back into z again if c equals 1. And z is going to determine this. But we only want to do this when c is 1. It doesn't really matter whether z is on, but we still want the z there in the test for the 1 stores b. So if b is negative 1, then we want to store 1 as z, because that means we're switching. But either way, we're going to store -1 into b, no matter what. So if b is -1, that means we're basically just going to save z to switch us later. But no matter what, we're going to store -1 into b for the time being. And then once c reaches 1, our timeout period is up, then we'll see if z was actually set. If it was, then we'll have to switch it to b. So now, no matter what, during the transition stage, he will run away from us. So now he's chasing us. Now he touched us. Now he's running away. And he'll continue running away, as he should. But now when we tag him, he runs away for a little bit. But now he's chasing us. And there, he tagged us. Now he's running away. And now he's going to continue to run away until we tag him again. So close. So close. Come on. Come on. Yeah. Got him. Okay, now he's running away. And now he's going to chase us. But notice how we don't have any kind of like... I used to try to play this game, but there was some kind of like annoying thing where we would just keep tagging each other all the time, constantly. There was no way to control who was it, because when we were together, it just kept switching. But now there's like this good timeout phase, and during that phase, he will always move away from us. So it will always be convenient to switch. So we tagged him. Now he's going to chase us, but he gave us a chance to, just at least not touch him during that time. So now he's getting away. We can't tag him when it's a Z. That's another thing. It gives him kind of a chance to get away from us, because we can't tag him when he's a Z. So he's chasing us. He tagged us. We can't tag him. We can't tag him. And now he's getting away, so we can finally tag him again. And there we go. We got a full game of tag programmed in TI Basic. And thank you for watching. I think this is all the time that I have for today. I probably made it a little longer than I wanted to, but I wanted to have a complete game and to show you how to create the entire game and also the design process. So I guess I'll just have to sacrifice the short episode to get everything in there like that. And now we have a complete game of tag. Thank you for watching, and I'll see you again next time.